presenting.
Good morning, good evening, welcome everyone. Today we've got a great session called Telemetry at Scale, Lessons from Building Observability for Distributed Systems. So our speaker today is Sneha. So welcome, Sneha. Thank you for coming and presenting to us today.
Hey everyone, thank you for joining the session today. It's great to be presenting today. Just to introduce myself, I am Sneha Parthasarathi. I am a software engineer at Microsoft. My expertise is in building and scaling modern containerized applications. So this topic is something that really excites me. And I've spent a lot of time building the Aspire dashboard on .NET and AC as well. So yeah, I'm excited to share my lessons.
Well, that's awesome. Hopefully we can all avoid the problems that you've ran into building out these systems as well. So yeah, it's always good. I think a lot of people, you know, they want to see all the nice shiny new stuff, and I think that's good because you need to know it exists, and B, you need to know where it sits, like where do you use this versus where do you not use it. But I think there's something that especially like from my perspective, it's like, oh, no one wants to read about that, but actually if you share your learnings, that's where people run into problems. So yeah, thank you. I'll just run through some housekeeping. So this session is delivered as part of the Azure Cloud Commanders Skilling Room. So within the Microsoft Tech community, you can go to Skilling Hub. There's community blogs, there's skilling rooms such as the Azure Cloud Commanders, which is this one, but there's other rooms for various other topics as well. So feel free to check that out. The rooms are developed and maintained by community members and some of the Microsoft Learn team. So thank you very much. It's all there, all free, all there. Start like discussions, have conversations, let us know how your learning journey is going and how we can all help. This is an inclusive session, to just be welcoming, respectful. There's no stupid questions. As soon as I hand over to Sneha to present, I'll kind of hide in the background so you don't have to look at me. and I'll be monitoring the chat as well throughout. So what we'll do is, if there's a question I can answer in the chat, I'll answer it in chat. If not, we can always wait till the end, or I can interrupt as well. But feel free to ask those questions. Right, over to you, Sneha. So thank you very much again. And if you wanted to present your screen, I can swap them around.
Awesome. Let me present.
Yep, I can see it coming up. So, right, over to you. Thank you.
Okay, great. Yeah, so today we're going to be talking about building observability for distributed systems. Just the agenda for today would be some introduction to containerization for folks that haven't used Docker or Kubernetes before, exploring the Container App platform. I'm going to be doing a live demo on this platform, so it would be helpful to understand what this platform does and how to use it, essentially. And I'll be talking about monitoring observability. That's the main topic for today with OTel, and I will also be doing a live demo with the Aspire dashboard and just techniques to debug a real-world issue. And then finally, we will go over some common anti-patterns and call it after. For folks that want to skip Docker and containerization, you can go ahead and look at this demo app that we will be looking at. But for folks that want to listen, you can continue to stay. So containerization using Docker and Kubernetes, right? You can think of Docker essentially as a lunchbox. It pretty much packages your meal. It packages every dependency similar. So Docker does the same thing. It packages your app. It packages your dependencies. It packages your libraries, and it's all in one place, right? So the meal that I have on my plate is going to taste the same as the meal on your plate, meaning the app that runs on my machine is also going to run on your machine and also on the cloud. So we wouldn't have situations where, oh, it runs on my local machine, but it's broken in prod. So Docker completely avoids those kind of scenarios. So what is Kubernetes? You can think of Kubernetes essentially as a supervisor that manages these lunchboxes and maybe hundreds of kids, if you will. Kubernetes, it places these containers on computers. It's responsible to keep these containers alive, and it also scales up and scales down depending on the traffic that each of these apps or containers are getting. It also load balances the traffic, and it is also responsible for rolling out these updates safely so we don't see any downtime in our apps. Moving on, so the Container Apps platform essentially manages your Kubernetes for you, right? Kubernetes is a pretty technical, complex concept, and it has a lot of overhead in how it should be maintained, and it can break, and the exceptions or the errors can be complicated to fix. The Container Apps platform on Azure pretty much takes care of all of that for you. You can think of it as a cafeteria that manages your lunches. It manages everything else that's going on in your application. So some things that it does here is runs your container without you having to manage your servers. This is a serverless platform, essentially. And it does everything that Kubernetes does for you, like auto scales up and down, depending on your traffic that your apps are getting. It deploys new versions as revisions without any downtime for your applications, and it also has built-in security and networking, so you don't have to worry about configuring like complex network configurations and NSDs and things like that. You can leave all of that to the platform. In addition, it also has observability hooks like Azure monitoring and log analytics, and also the Aspire dashboard that I will be talking about in a bit. So what is observability? We've been talking about meals and cafeteria and kitchen. So you can think of your app as a big, busy kitchen, right? And observability essentially tells you what's going on in your kitchen, what's going on in your app. It gives you more insights into your health of your app, how your app is doing, the traffic, and all of those good things. And this is especially useful in a microservices architecture in a distributed setting, because with observability, you essentially know where the request went to each of the services and its trace and things like that. Unlike monolithic applications where you just have like a single application, and it would be super hard to figure out what exactly went wrong when the application fails. So observability essentially has three components: logs, traces, and metrics. Logs essentially tells you what is broken in your application. Traces and spans tell you where it's broken. You can think of a trace as a full lifespan of a request. A trace is going to tell you everywhere or all the services that your request passed through. And a span is a single unit of that trace, which you can dig deeper into a single span and look at each component within your microservices architecture. And metrics essentially tells you how your application is doing, or just why your application broke or failed if it did. Okay, awesome, great. So now I can talk a little bit about the demo app, but before I go into the architecture, let's go into Microsoft Azure and look at all the services that we have deployed. So essentially I have this resource group, and within the resource group, I have 6 services for my demo app, and they're all deployed within an environment. Before I go into what each of these services does, the demo app is essentially it's an agentic AI commerce app, which essentially has agents that makes negotiations for you when you buy products. Let's look at the app real quick. So here we have a bunch of furniture, we have beds, we have tables, we have sofas. So a user essentially would pick any of the items that they want, and then they could essentially put what their budget is and their delivery date, the color, things like that. There's a buyer agent and a seller agent which negotiates a deal on your behalf, so it benefits both the parties. You guys can play around with this. There is a bug that we're going to debug, so brownie points for folks are able to figure out what the bug is. But before we play with the app a little more, let's go into the architecture and understand how this is all going to work together. So the Agentic Cart app has a front end, React, and there's a backend service called the API Gateway Service. Pretty much any request that gets routed from the front end first goes into the API Gateway Service, and then it gets routed to the 6 other services, which is the buyer agent and the seller agent services that I was telling you about, then the inventory service that keeps track of all the inventories of all the items, the payment service, and the shipping service. We're using Azure Redis here for state store that gives us all the context about the conversation, what the agents have had, order history, inventory stock, things like that. And like I mentioned before, these 2 agents are talking to Azure OpenAI to make a deal that would be best for both the buyer and the seller. We're hooking up all the telemetries from all these services to the Aspire dashboard using OTel and OTLP, and we would be able to see metrics, traces, and logs on that dashboard, which I will show you in a bit. Okay, awesome. So let's revisit all the services that we talk about. We spoke about the buyer agent, the seller agent, the payments, the inventory front end, and the Redis state store. We have the Foundry model here. I'm using GPT 4.1 for this demo, which is what is deployed in my Azure Foundry. And we have this Agentic Cart environment, which is the Container Apps environment within the Container Apps platform. And each of these services that I talked about are all deployed as Azure Container Apps in that environment. So if we go into that environment real quick, we're going to see all the services that's deployed as apps here. Okay, awesome. So back to the hotel demo. So I have my Aspire dashboard enabled here. Let me go into that. If you guys notice, the way the authentication works is it is a single sign-on authentication. So it's going to ask you for your email or your corp account, and then it will validate against the permissions. The users are required to have a contributor permission on the Container Apps environment level to be able to access this dashboard. So now we're seeing all our services deployed here, and we're also seeing their latest revision. So this is the latest version. You can think of revision as the latest version of your app that's running. And So this dashboard pretty much gives us all the information about the state, the image, the time that the container started, the URLs. So you can directly go to those URLs from the dashboard here. There are also some other actions you can do, like stop the resource, start the resource, look at console logs, all that good stuff. The console logs keep streaming. You can pause it if it's noisy. But yeah, so those are the two features. Our hotel metrics are wired into structured logs, traces, and metrics here. So that's kind of how the dashboard works. And this is what we're going to use to debug our demo today. So going back to this, we can look at a few happy cases and see how this app even works to begin with. For instance, let me choose this. So let me add a budget of 600. It says the base price is $8.99, but I can add whatever budget I want, right? Because both the agents, the buyer and the seller agent, they're going to talk to each other and figure out if the seller agent can actually make this order. Let me add a date. Let me use the color Urban Fog. It's going to take a bit for the request to actually go through to the agent, and then okay, awesome. So here you can see the full conversation between both the agents. The buyer agent, it placed its request. The seller agent negotiated. You can see here, right? It says, oh, the budget is $600. That's below the minimum price. And it made some negotiation. There was some back and forth with the buyer and seller, and they actually were able to come up with a deal. So they made that deal, and the order was created, and the status was completed. Let's look at another case. What if my budget is like $10, right? This has to fail. At delivery date, let me use the color Haute Cloud. So you can see that it almost immediately failed, right? Here, both the agents, they still tried to make a negotiation. As you can see, the buyer agent tried to place an order, and the seller agent here says, oh, no, this is significantly smaller than our minimum price, and the order failed. So you get it. That's kind of how it works here. And we can also go see there's like an order history where we can see the orders that failed, orders that completed. So yeah, that's kind of how this app works. If folks still haven't figured what the bug is, we can go into that. So today I will be demoing the timeout cascade bug. I can show you how that works here real quick. So this is not an actual bug. This is a simulation. So if I try to place an order on this walnut sofa, let me say my budget is way above the minimum price, right? I have like a $900 budget. Then I set the delivery date, and let me choose the color Toasted Pecan. So this is just a bug that is expected to fail. It's going to wait for a few seconds till it times out, and then it's just going to tell us that, hey, this timed out, and then we'd have to debug why it timed out. Okay, it said it failed. Let's go into the dashboard. Since our first point of contact is the API gateway, so that would be a good starting point for us to figure out what exactly failed. And we have a metric here that says orders.failed, right? So this is going to tell us, this is a very good starting point for us to know why something failed. So here, right off the bat, we know, oh, there's some issue with the shipment. So we know where to go next. We can also look at some other metrics that we have here, like the count of orders that started, and also the duration. So here we see the P90 milliseconds, the P50. It's more important to look at the P90 than the P50, because P50 milliseconds metric is just going to tell us the average, and the P99 is going to tell us more important things like, oh, why did it succeed for 99% and fail for the 1%? And here we have more filters with the step and the shipment. We're more interested in shipment here because we know that the reason that it failed is because of some issue in the shipment. So now that we have looked at the metrics, we can go look at traces and see what information we can get from there. Oops. Okay, we're seeing some error. We can filter this by error. Okay, so here right off the bat, we see the full flow of the request, right? Like I mentioned before, a trace tells you all the services that your request moved through. So here we know that it tried to start the purchase, it talked to the buyer agent, and the buyer agent tried to reserve the inventory, and it tried to charge the payment. All of those requests went through, but there is no request after create shipment. So we know right off the bat that something is definitely wrong with the create shipment method. And if we go into this, we see that, okay, so the sofa that we chose for this demo is walnut, and we know that this is telling us a lot more information, like what sofa failed or what product failed. And it also tells us what category, the exception type, and the stack trace also, which would help us dig deeper into where exactly this issue has been occurring. So now that we know that something is wrong with our shipment service, we can go into our logs and try to figure out where these errors are coming from. So let's go into shipping. I'll reload this. Okay, looks like I can run the load test again and get those logs. So this load test, essentially, it makes 50 requests against the buying service, which would place an order to buy the sofa that we know that there's a bug in. And then we can go look at the logs to see, we can go look at the shipping logs now that we know that something's wrong with shipping, to see where exactly the log occurred. Okay, awesome. So now we have these shipping logs. And here, if I go into this tells me very clearly that there is something wrong with my carrier API. And it also tells me the seconds that it took. So we know that this is a timeout issue. And now from this message, we know where exactly to look for. We know the category. It also tells us a bunch of other information like the name of the service, the name of the environment, the name of the namespace, and what metrics, what framework we're using for metrics, things like that. So what I can do now is just copy this log message and go look at our code and see if we can actually find where this this message is. Control V. Okay. So this is the log that we were seeing. And this is exactly the number that we were seeing in our logs as well from our Aspire dashboard. And if we come down here, this is the bug. We're awaiting the delay for all these milliseconds, which causes timeout, and it causes the shipment service to fail. So we can easily fix this by getting rid of the so that is my delay, and that's where I'm awaiting it. So we can comment this out and ask Claude to, I have Copilot and Claude. I use both interchangeably, but I can ask Claude to build my shipping service and deploy to Azure Container Apps. So essentially what this is going to do under the hood is build this Docker file, push it to my ACR, and update the container app by running AZ container app update from the CLI. Or the other way to do this is by just going into the portal. And when I have my image built, I can just go into the shipping service, and then I can go into revisions and replicas and create a new version with my new image. So that's pretty much it. So I can just create a new revision and deploy that. So that would also update the container app. And then when it updates the container app, we would be able to see a new revision that shows up here. And that should fix our that should fix our bug, and our walnut shopping or shipping that will succeed after.
That's awesome. I have a question.
Mm-hmm.
So with .NET, with Aspire, like obviously the capability of being able to see those traces and view it is a lot, like it's a lot easier than just literally going into the log stream for those services.
Yes.
Would you have, like in this example, like .NET Aspire is running on the same app, like container app service, right, than the app itself? Like, would you separate it out in production? How would you architect Aspire?
Yeah, so the Aspire dashboard, you rightly pointed out that this is also a service under the hood. It doesn't show up as an external service here in the environment, but it's deployed as a container app in the container app environment. And the way that this works is each of these services, they emit hotel metrics to an hotel controller that you don't have to configure if you're using the Aspire dashboard on the container platform, because it's auto-configured for you. So under the hood, these services emit these hotel metrics to the hotel controller, and the hotel controller exports those metrics to this dashboard that we're seeing here. So this dashboard, it's an internal container app under the hood. There are two container apps, one for the dashboard image, there's
Mm-hmm.
a local Aspire dashboard for .NET scenarios. So it's the same image that we're using. And there's a backend container app which gets all the information from Kubernetes API. Essentially, these services are all deployed in your AKS cluster. So the Kubernetes API queries all of the data that we're seeing on the Aspire dashboard and talks to the Aspire dashboard over gRPC. And that's how we're seeing all these metrics here.
Yeah, thank you. Yeah.
Awesome. So let's see if this actually finished. Okay, so now it's just asking me if I want to update the container app, say yes. That's going to take a bit. But yeah, what's going to happen after that finishes is, like I mentioned, we're going to see a new revision with the bug fix under revisions and replicas. And that would have like the latest version. Also, another thing I want to point out is while that version is deploying, there's zero downtime, right? The previous version is still going to be running. It's going to run till the latest version is fully active and ready to take traffic. So there's zero downtime between switching between revisions.
Yeah, I love that with container apps. It makes it a hell of a lot easier, especially if you have health probes. And it's like,
Yep.
My app will exist. It's awesome.
Yep.
There's no questions in chat, but I will just point out for those watching that if you do have any questions, feel free to put it in chat and we'll see if we can answer it.
Awesome. If there aren't any questions, I can move on to the last slide.
Okay. Yep.
So we did talk about how to set up traces, metrics, logs, all of that good stuff. So the few things that we need to keep in mind is these logs and the structured logs, metrics, everything, all the OTel components, these help us in debugging our incidents at 2 a.m. The goal of adding these metrics is to make our lives or make the lives of SREs or devs easier at 2 a.m. when the app is broken and there's an angry customer that's yelling at us. So it's important that we add human readable filters and human readable identifiers and avoid using things like SKU names or like GUIDs. So that's just going to slow us down when we're debugging the issue. The other thing is we need to pay more attention to the P99s, like I showed all of you in the demo, because P99s give us a lot more information about the 1% customers or 1% apps that are failing. P50s are usually the averages, so they hide a lot of details and may mislead us into believing that our app is doing perfectly fine and the health is great. The other thing is in the metrics, if you folks saw, we had a dimension that told us exactly which service was failing. In our case, it was the create shipment. So it's important for us to also add a reason dimension. So when we look at the metrics, we know what exactly is failing, and then we can go back to our traces and look at the lifespan of the entire trace to figure out where things are failing and go look at the logs to figure out what exactly is failing. So those are the main things to keep in mind when designing observability for distributed systems.
Thank you very much. Yeah. I'm going to go, I'm running a couple of app services at the moment, so I'm definitely going to take those considerations into being. I think wrapping .NET, because they're .NET apps as well, so I think wrapping .NET Aspire to it, some of the open telemetry calls, and just making a bit more human readable, I think makes a difference as well, because yeah, it's hard to trace when you're going let me just run this, see if
Yep.
it works. Okay, there's a failure, but I think being able to trace it and then see the time that it takes to make those calls as well actually can help optimize, especially going into production. So
Yep.
there's no questions in the chat, but Sneha, if anyone else has any questions or thoughts, how can they reach out to you?
You folks can reach out to me on LinkedIn. I'm pretty responsive on LinkedIn. Yeah, I'm happy to answer any questions.
Awesome. Thank you for coming and donating and presenting to us today. Very insightful. I've taken a picture of your anti-patterns. Very useful to have top of mind as well. I think hopefully everyone watching this, it's been useful for you as well. And I think just keeping in mind of those anti-patterns helps avoid all the issues that Sneha has pointed out and fixed with us today. So thank you very much. We'll end it here, but yeah, feel free to reach out to Sneha on LinkedIn. I'm sure you can find it quite easily if you have any questions, but thank you for coming and presenting to us today.
Yeah, thank you so much for the platform. I had a really good time sharing my experiences and sharing what I've learned. So it's great to be here.
No, it's great. Thank you for, yeah, I think we mentioned it at the beginning. I don't know if it was recorded or not, but I think a lot of people, like, we want to see all the new shiny new functionality, but I think it is definitely worthwhile sharing all the gotchas and learnings about real world applications.
Yep.
So yeah, definitely worthwhile. Just